Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Alex Nicolaitis, the webcast coordinator for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the question and answer window on your screen. After the presentation, we'll begin the Q&A portion and I'll ask our speaker your questions. Your questions in the Q&A window will only be visible to myself and our speaker. So thank you for joining us today. It's now my pleasure to introduce our speaker, Manuel Matos, PhD Field Application Scientist from Thermo Fisher Scientific.
Hi everyone, thank you Alex for that kind introduction. I'm very happy to talk to you today about innovation of novel purification strategies, specifically a case study for a Clusterin Scavenger resin, which originated from our custom resin development program. So without any further delays, I will start my presentation by showing you the growing diversity of biological molecules in development. As you can see on the chart on the left, the major portion of molecules is still monoclonal antibodies, but there has been increasing interest in viral vectors, nucleic acids, and cell therapies. So with this rise of new molecule modalities, this leads to new purification challenges, which drives the need for additional tools for purification. But just to speak a bit about antibodies and its workflow, we know that one of the major challenges is the removal of difficult to remove impurities, such as one of them host cell proteins. So a customer has approached us with a difficult scenario, which was for the removal of Clusterin. So Clusterin is a host cell protein from the CHO cell line, and it associates with the product. So it is known to piggyback on antibodies and to be co-purified along the whole purification train if there is not a scavenging resin in place. On the left, you can see a table listing different host cell proteins that are known to be difficult to remove and their estimated strength of interaction with the monoclonals. And we know that the mechanism of interaction is through non-specific interaction, specifically between hydrophobic patches and hydrophobic contacts, and that these interactions are enhanced in MAB clusters. So when a scenario like this appears, one of the more straightforward approaches would be to test conventional purification technologies to remove these impurities. However, when that doesn't work, an alternative route can be considered, such as the creation of a custom resin for that specific target molecule. So this speaks to my next slide. Why should we pursue a custom resin? And the first reason I already mentioned, so that when there's no suitable chromatography resin available. The second reason is that you may already have a purification process in place, but the resin lacks specificity, so the chemistries do not allow you to have the capacity or the resolution that you want. The third reason may be because your current process is not scalable, because of the technologies you are using are not cost efficient. Another reason may be the molecule requirements, so the available chemistries restrict your design space, or the operation conditions are not suitable for your process. And the last reason may be to increase the process efficiency and reduce cost of goods by having this high yield and high purity step. So at Thermo Fisher, we have a very powerful technique called capture select technology, which is used for the generation of new affinity ligands. And we can use this technology and take advantage of it to design a custom resin for a specific need of our customer. So just to talk to you a bit about our capture select technology, It is based on the VHH domain. So VHH is that small domain shown on the image, originated from the antibodies of camels. It is only 15 kilodaltons, but it retains the specificity for the antigen. So we at Thermo can create big libraries of these molecules, and then we can screen it to select the best candidates for an affinity resin and target and screen it for target specificity, mild dilution, and also stability. These ligands are produced at large scale in yeast, so this is a completely animal origin-free production process, and a lot of our products are already in commercial purification processes. We also have a proven custom ligand development program, which I will talk to you in the next slides. So for you to have an idea of the whole process of development of affinity resin, we divided it into different work packages. So this is a milestone-based service, and we typically start with the library construction that we can use between 1 to 10 targets for this construction. We can start with pre-existing libraries, or we can even create multi-target libraries. So it's dependent on the customer needs. We then move on to the lead screening, which we start from 200 or so candidates, and we start to reduce the number of candidates down to 6. And the criteria for selection is usually specificity, binding kinetics, mild dilution, and also the stability of the ligand. Once we have our 6 candidates, we move to prototype resin testing. So this is already in the column format, and we screen for the scalability of the ligand, how good is the performance on a one-step purification, the elution profiles, and also the ligand stability. We typically select 2 candidates and move on to the next work package, which basically compares the scale-up of both prototypes and also the performance of the resin under process conditions. So we take all this data to select our lead binder, and then with the final work package is the suitability of the resin for a GMP process. So in order to have the final resin, we do the process validation, which is usually 3 times a 5-liter batch, and we provide also leakage ELISA and also regulatory support files. So I've mentioned only capture select custom resins, but we actually can have also custom resins through our porous technology. So they all fit together very nicely to increase the number of options we are able to provide to our customers. So we have already spoken a bit about capture select, but if you look on the image on the porous resins, it's being used by a lot of the top biopharmaceutical companies. It is considered to be a standard product in a lot of commercial processes, and we offer a very wide range of batch sizes. But what is important in this slide is the customer process. So we are able at Thermo Fisher to provide you with a fully validated resin manufacturing process. We supply you with regulatory support packages, leakage ELISAs, and other analytical tools. And we also have supply redundancy of supply due to our high number of manufacturing facilities throughout the globe. In terms of track record, we have this distribution among different classes. Most of the projects are in proteins, and inside proteins we have a lot of projects on enzymes, blood factors, fusion proteins, plasma proteins, so a lot of different options. Since 2003, we have more than 60 projects with a very high success rate, so more than 90% in identifying lead candidates meeting predefined requirements. So moving on to talk a bit about the product and some data. As I've mentioned, the customer approached us with a problem, which was the removal of clustering. So we developed this porous capture select clustering clear scavenging resin. Some of its benefits is that you are able to provide clearance of clustering and also other host cell proteins following product affinity capture. Because it is based on our capture select and our porous technology, you can have high productivity and high specificity in the scavenging resin. And also because it works in a flow-through mode, you can have a simple, small footprint, which is very easy to implement in large scale. So we started off by quantifying host cell proteins and clustering amounts in the clarified harvest and also on the MapCapture-C elution pool. So when you look at the harvest, we have very high concentration of host cell proteins, and on the MapCapture-C eluate, we are able to remove up to 98%, which is very good values. However, if you look at the reduction of clustering on the blue bars, you see that only 86% of reduction is possible. So what this means in practice is that the clustering levels increase eightfold in the elution pool after the MapCapture-C affinity step. There is this very disproportional reduction of host cell protein versus clustering clearance. So this is where the porous capture select clustering clear resin comes into play. So we use the MapCapture-C eluate as the load sample for the clustering clear, and we screened 3 different load concentrations, and we obtained these results. So we are able to remove very efficiently clustering from the samples, and we see more or less independent effect on load concentration. When you look at the overall host cell proteins, host cell protein amount, we see more or less a similar trend. So we are able to remove and clear up to 82% of the overall host cell protein. So this is a very interesting clearance, which made us very enthusiastic. And in terms of ppm, we are able to reduce it up to in the order of 100 ppm, which shows the robustness of the performance. So my final slide is just some general features to summarize the properties of this resin. So as I mentioned, the support matrix is based on our porous technology. So this means it is a cross-linked polystyrene divinyl benzene backbone. The ligand itself is a VHH ligand. The capacity estimated is more than 8 grams per liter. Particle size 50 microns, and we recommend resonance time more than 1 minute. In terms of mechanical resistance, it has a high pressure limit up to 100 bar, and on the right you can see some of the SKUs in case you want to order some resin. We also are able to provide you with larger volumes upon request, so feel free to reach out in case you are interested in this product. With that, I finish my presentation, and I'm happy to hear some questions.
Okay, great. As a reminder to our audience, you can go ahead and type in your questions for our speaker now. So our first question is, if I'm interested in a custom resin program, do I need to start from the beginning of WP1?
Thank you for that question. So the answer is no, we do not need to start from the beginning for package 1. You can jump right in from the work package from some of our capture select products that are currently being developed in pipeline, and we can provide you with a list that the products that are now in the pipeline. And you would only need to start from the beginning if it's a completely new target molecule that we never worked with, and in that case, you must come from the first work package.
All right, well, it looks like we're running a bit short on time today, so if we don't get to your questions, we'll be passing them along to Manuel, who can follow up with you directly. So please go ahead and continue to type in any questions you have, and we'll get those passed along. The last question for the webcast is, can I use this resin for scavenging HCP immediately after harvest, therefore skipping the affinity step?
Thanks again for the question. The product was implemented after the first affinity purification step, so after protein A, which in this case was mark capture C purification. But you can also use it immediately after harvest. So you probably will not be able to have as good clearance as using it after affinity, but you can definitely use it before if you wish to compare the performance on both cases.
Okay, well, thank you, Manuel, and thanks to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.